Hello students, welcome back. So now we are going to discuss about the methods of preparation of alkyl halides. So how these alkyl halides are formed from other compounds. So let's discuss about it. So before we see the classification and as well as IUPAC nomenclature, now we will see the preparation of alkyl halides. So in how many ways alkyl halides can be prepared? So here I am showing some of the ways. One is from alkanes, another is from alkenes, and from alcohols also you can prepare alkyl halides. And this there are two named reactions which are very important regarding this alkyl halides. That is, one is Finkelstein reaction, which is also known as halide exchange reaction, which is a preparation method of alkyl halides, and other is from silver salt of carboxylic acids. So this reaction is known as Borodin-Hunsdiecker reaction. So these are the 5 methods of preparation, and out of which these two are the named reactions which are important. So let's see how we can prepare from alkanes first. So from alkanes, they react with halogens in the presence of light, to give halides. So the reaction is, this is the alkane which is reacting with chlorine in presence of light. So here, for this reaction to take place, light is required. So in presence of light, it gives alkyl halide along with HCl. This is the reaction. If I take methane, I am getting methyl chloride. So by the reaction between methane and chlorine in presence of sunlight, we will get the alkyl halides. So alkyl halides further react with halogens to give di, tri and tetra halogen compounds. So if I take this chlorine in excess quantity, then what happens is, because the methane will react with some of chlorine and it will produce this one, and this will again react with the remaining chlorine, because I am taken chlorine in excess quantity. So this more than sufficient amount of chlorine is left out in the container. So this methyl chloride will again react with the chlorine and it will produce CH2Cl2. If more amount of chlorine is available in the reaction mixture, then this will further react with chlorine and it will produce CHCl3, which again may produce CClO4 depending upon the amount of chlorine that we are taking. So if I take chlorine in excess quantity, I will get di, tri and tetra halogen compounds. So the reaction between the methane and chlorine, so if I take chlorine in excess quantity, so I will get these 4 products. So I am not getting one product essentially, but I am getting a mixture of the products. This is monohalogen derivative and this is trihalogen derivative, and this is in which the 4 chlorines are present. So the substitution of hydrogen atom in halides follows the order. So tertiary hydrogen, the secondary hydrogen and then primary hydrogen. So this is the substitution, the order of preference. So like if here this is the simple compound, but if I take this one CH3, CH2, CH3, all hydrogens are not attached to the same kind of carbon. These two are primary carbons, but this is secondary carbon. So this reaction is actually free radical halogenation, free radical reaction. So there is a formation of free radical. So if this hydrogen lost, that is in the middle, by homolytic fission, you will get secondary free radical, which is more stable as compared to primary, and tertiary is even more stable as compared to secondary. So tertiary hydrogen is going to be replaced first and then secondary and then last primary. Okay, so I will get tertiary as the major product and the primary as the least product. Okay, so here I am getting the 4 products, the mixture of products. So if I want to get only the methyl chloride in excess amount, I only want to prepare, I don't want a mixture, I only want this methyl chloride in excess quantity. I want only this product in predominant amount. So what I can do? So instead of taking chlorine in excess, take methane in excess. So if you take methane in excess, so you'll majorly get this product. You won't get other products because chlorine is not in excess quantity to give all other products as well. Okay, so this is from alkanes. So let's see how we can prepare alkyl halides from alkenes. So one of the ways you can prepare by addition of hydrogen halides on alkenes. So you can see the reactions which are yielding the alkyl halide as the product. From the starting product we are taking alkene. So this is propene. So propene on reaction with hydrogen halide, that is HBr. So it will produce this 2-bromopropane. So this will be the major product. 1-bromopropane will be very minor amount, because secondary free radical is more stable. So this is from this reaction is occurring through free radical. And if you see this one, in this case we are getting the primary one, the primary bromine. This is N-bromopropane. So 1-bromopropane you can say. Here bromine is present at the primary carbon, which is possible by taking these two. So if I take HBr in presence of ROOR, so here I will get the primary has the major amount. So not only the secondary, there are other reactions are available for us to get the primary in the major amount. So let's see from alcohol how we can prepare. So here first is the reaction with halogen acid. So halogen acid is nothing but HX, halogen acid. So it may be hydrogen chloride, hydrogen bromide and hydrogen iodide, etc. So the reaction with halogen acid. So if I take alcohol which reacts with halogen acid and it produces alkyl halide along with water. So this is the simple reaction, and the reaction with phosphorus halides also yields alkyl halides. So here the phosphorus halides, this may be phosphorus trihalides or phosphorus pentahalide. For example, PCl3 and PCl5. So the alcohol yields alkyl halide with both PLC as well as PCl5. So not only tri but also penta phosphorus halides. The PCl5 will also yield that alkyl halide, but the byproduct is different. So if you see here, the 3 moles of ROH will react with 1 mole of PH3 to yield 3 moles of RX, and along with we are getting phosphoric acid. And here if I take ROH along with which reacts with pentahalides and it yields RX, but we don't get H3PO3 as byproduct, but we get PX3, that is phosphorus trihalide will get if I take phosphorus pentahalide as the reactant. Okay, so just see, they may ask you that how many moles of alcohol is required to get 3 moles of alkyl halide with PX3, 3 moles. Okay, so what is the byproduct in the reaction of alcohol with phosphorus pentahalide? So that is the byproduct is PX3 as well as HX. Okay, so this is the second way, and third way is reaction with thionyl chloride. So thionyl chloride is SOCl2. SOCl2 is the thionyl chloride, so which reacts with alcohol and it yields especially this alkyl chloride, because we are taking thionyl chloride, so we will get alkyl chloride as the product. Okay, so next is Finkelstein reaction, which is a named reaction. So let's see what is the Finkelstein reaction and how and what are the halides that we can prepare through this method. So alkyl chloride and bromides react with sodium iodide in acetone to give alkyl iodides. So here this may be alkyl chloride or it may be alkyl bromide as well. So it may be RCl or it may be RBr, which reacts with sodium iodide in presence of acetone. So acetone is a solvent here, sodium iodide. So I am getting alkyl halide. So I can only prepare halides plus NaCl. Okay. So this reaction is known as Finkelstein reaction or halide exchange reaction. So if you can see, the chlorine is substituted by iodine. So it is a kind of halogen exchange reaction. Okay. So even if I take RBr, that iodine and bromine will get exchanged, and I am getting, so you can see the chlorine and iodine are exchanged between the two. So iodine came to chlorine position and chlorine went to iodine position. So that's why it is also known as halogen exchange reaction. But the important thing in this reaction to remember is, this reaction is possible because the sodium iodide is soluble in acetone, but NaCl and NaBr are insoluble in acetone. So that's why this reaction is possible, and here RF does not yield. So sodium iodide does not exchange it with RF to get Ri. Okay, so that one more thing keep in mind about this Finkelstein or halogen exchange reaction. So let's move to the last method of preparation, that is Borodin-Hunsdiecker reaction. So what is this method? So in this method, this is the silver salt of carboxylic acid. So RCO2H is the carboxylic acid. RCO2H is the carboxylic acid, that is RCOOH. So when it reacts with a base, so this hydrogen will be gone and silver will be there here. So this is the silver salt of carboxylic acid, will react with bromine in presence of CCl4 carbon tetrachloride solvent, which yields alkyl bromide and CO2 gas and AgBr as the products. Okay. So if I take chlorine, I will get RCl. If I take bromine, I will get RBr. If I take chlorine, I will get RCl. Okay. So this reaction is followed through the free radical formation. The mechanism is through the free radical formation reaction, but you cannot prepare iodides, you cannot prepare Ri through this method. The only limitation, like this is the limitation of this reaction, only you can prepare RBr and RCl, and you cannot prepare Ri, because the iodine, it forms esters instead of alkyl halide. So the reaction is going to be like, instead of getting alkyl halide, you will end up with getting esters. Okay. So you cannot prepare alkyl halides through this method. Alkyl iodide you cannot prepare, especially bromide and chloride you can prepare. So with the reaction with iodine is known as Binbaum-Simonini reaction. Okay. So that is Binbaum-Simonini reaction with the silver salt of carboxylic acid with iodine. Okay. So these are the few methods of preparation of alkyl halides from alkanes, alkenes and alcohols, halogen exchange reaction and this Borodin-Hunsdiecker reaction. So students, in this part we discussed about the methods of preparation of alkyl halides. We have discussed how alkyl halides are formed from alkanes, alkenes and from alcohols. So we also discussed about two important named reactions. One is Finkelstein reaction, other is Borodin-Hunsdiecker reaction. So this is about the methods of preparation of alkyl halide. So now I am going to put a question to you. What do you think? These alkyl halides are soluble in water or not? Whether they are more denser than water or not? So to know the answer to these questions, you have to wait for my next part.